Hi everyone. In this video, we're going to go over multiple regression. So multiple regression, it helps us to find if there is a significant relationship between two variables or multiple variables. And usually we have a dependent variable. And in multiple regression, the dependent variable has to be continuous, right? Otherwise, Microsoft Excel will not allow us. At least this is in multiple regression. But if we have a categorical variable, that will be something else we will talk about later on when we talk about machine learning and data mining later on. But for now, when our dependent variable, or we call it outcome variable or a target variable, or the effect, right? So the dependent variable is the effect, and we are trying to find the causes or the predictors of this variable, dependent variable, right? When we have only one continuous variable as a independent and one variable as a dependent variable, we can use we call it bivariate regression or simple regression or correlation. We can use correlation as well, right, to see the relationship between those two variables. Or our independent variable can be continuous or dichotomous. So dichotomous here, or binary, or 0 or 1, or a dummy variable, right? Those are different names for dichotomous. This is when you have either or, right? Like, for example, male or female, white or non-white, and so on. Those are just some examples of dichotomous, right? Zeros and ones, and so on. So if we have one independent variable, one dependent variable, we call that simple regression or bivariate regression and correlation, right? But if we have multiple independent variables, whether they are continuous, dichotomous, so continuous meaning that they are like height, weight, dichotomous is like gender, or a minority or not minority, just zeros and ones, right? And we have a dependent variable that is continuous, then we call that multiple regression. So multiple regression helps us because we can use several variables at once as independent variables. It helps us isolate the unique effect of the variable that we want to say. We can say, for example, the number of siblings impact salary regardless of age and education and so on, right? And we can write a mathematical equation using multiple regression, and we can control for other variables. So look at this. Let's have a look at this example. We have this data set. We got it from the city of Chicago, and it's and this data set that I provided to you in Blackboard, we are going to have a look at it. It's an Excel sheet that has several variables, and we want to test or do multiple regression using education and experience as independent variables or predictors of salary. So salary is our outcome variable. It is our dependent variable. It is our target variable, you can say, or it's the effect, and we want to see if education causes salary or impact salary, and experience impacts salary, or if there is a positive or negative relationship between education and salary and experience and salary, right? So you are assume that you are a behavioral scientist and you want to be you are interested in finding the relationship between those variables. So we state the research hypothesis. Remember when you took your stats course, you were introduced to alternative hypotheses and null hypotheses, right? So in science, usually we state the hypotheses in our research scientific papers as alternative hypotheses. So in this case, this is the alternative hypothesis that we want to test if it holds or not, right? If it is supported or not by the data that we have. So there is a positive relationship between education and salary, right? That means as education of the respondents increases, the salary will increase. Same thing here, another hypothesis, there is a positive relationship between experience and salary. So let's see and test this relationship between education and experience as independent variables and salary. All right, so the null hypothesis, I will skip that because we don't, in science, we don't use null hypotheses, but let's see. So mathematically, this is how we write the equation. So the y, that's the expected salary that we want to predict. So will equal a, which is the y-intercept. So the y-intercept, this is when, for example, when we had, so let me see if I can type. Remember when we had the coordinates? So this is the y, and this is the x. So the y-intercept, it is any point when the x is 0. So the x is 0 at this point. So it can go from here if it is positive, it can go. But this is the a, right? And then the b, b1 and x1 and b2 x1. So you got that's the beta coefficient of variable 1 and beta coefficient for variable 2. And when we run the relationship or the regression, multiple regression analysis in Excel, this is the results that we got. So this is the A, and this is for education. Actually, we put here education as x1. And this is the beta coefficient for experience in terms of number of experience in terms of weeks, right? Number of weeks. And this is, so in other words, so this one, negative 21,000 might start here. That means if education is 0 and experience is 0, so the person needs to have 21 to survive. You can interpret it like this. But now, when we run the Excel analysis, this is the output we will receive. So all we need to look at, the R squared, which tells us the percentage that education and experience explains in terms of salary. Or you can say education and previous experience predicts 44% of salary. So that means the other 40, actually, the other percentage will be predicted by other variables. So in other words, only those two variables predict 44% of the salary variance, right? And this is the fancy way to say 44% of the variation in salary is explained by education and experience. But you can say education and previous experience explain 44% of salary, or predict 44% of salary, right? So this is the y-intercept. That's what we put it here, the A, right? Remember? And then this is the coefficient, the beta coefficient for education. We put it here. It's a positive, and also the beta coefficient for previous experience. And then we look at the p-value, right? So the p-value here is very low for all of them. So that's why we say they are significant. At least we look at the p-value of our predictors. So they are significant. They are below 0.05. So they need to be below 0.05 for the relationship to be significant. Okay, keep that in mind. So those education and previous experience, they are significant predictors of salary because their p-value is lower than 0.05. All right, so now we can actually build our equation. And this is the best way to build our equation. Expected salary will equal this, and then we can plug in. So we can plug in here 1, or here 1, or and we can plug in and see what are the output or the expected salary. So I provided to you a table here. When we plug in, when education is 0, so this will be 0. So multiply by this, it's going to be 0, the output, right? And this one is going to be 0, so it's going to be and this one will be 0. Multiplied by that will be 0. So this will be our output, right? The expected salary if they have education, 0 education and 0 experience. So if they have 20 years of education and 0 experience, then their salary, expected salary is going to be around 60,000. And then you can plug in the rest, but you got the idea, right? So now let's run this analysis using Excel. All right, so let's see. All right, so now let's go to Blackboard, and I already actually have those files for you here. Already downloaded it. So let's click on this guy. All right, so this is the data set that I provided to you. And this is our Y, is what we're trying to predict, our output variable. And we said education and previous experience, those are our independent variable. So we want to analyze this data, and we want to do this using under data. I need to see data analysis. If you don't see data analysis under the data tab, then you will need to go to file and then go options, and then from options go to add-ins, and then from add-ins click on go, and then make sure that you check the analysis tool tag and say okay. All right, so now I can see it. I will click on it, and then I will just go from here and do regression. So my Y input, it is the salary. I will select that H1, and then I will click on Shift and Control and then downward arrow. That way it selects the whole column for me. Then I will put my cursor inside the input for the X range. So I'm going to select D and E, and then Control and Shift, and still holding them, and then the downward arrow to select the whole all the columns. And then I will select labels. I need to make sure that it is checked. And it's a new worksheet. You can call it here edu underscore experience and experience, right? You can call it that way. And then I will say okay. So now it created for me the output. So let me organize this one. I'll just make it numbers. Oops. So I'll just keep it as numbers because I'm interested in highlighting this one. So this is my R squared, so 44%. And those are the coefficients that we need to include in our equation. And we're interested in the p-values, which tells us whether the predictors are significant or not. And this is the significance of the model itself. So it is very highly significant, right? So those are all that we need to look at when we are evaluating our regression. So we can see that education, and this is exact results that we got from our from here, right? So this is the y-intercept. We put it here, and this is the beta coefficient for education. We put it here. It's a plus, and this is the beta coefficient for experience. We put it here. So you got the idea, right? So now let's move on. So I will let you test this one by yourself. So you want you to look at the educational level and number of siblings and how that correlates or regresses on salary. So now let's do multiple regression with more variables, right? So we have education, experience, gender, and minority, right? So we'll do the same thing. We will list our hypotheses, right? And then we are going to run our regression model using this for variables. And then when you run the analysis, this is the results that we get from Excel. So the y-intercept, and then we get the beta coefficient for education here is different now because there might be correlation within with the other variables in the model. And then we have gender, it's negative, and minority is also negative, right? So the expected salary equals negative 5,000 plus 3,000. So in other words, we need to interpret what this result tells us. So it is telling us that if education and there is zero education, there is no gender, or there is no minority, so the 0 0, right? And then actually the relationship here, or the expected salary is going to be negative 5,000. So in other words, it doesn't make sense as a practically, but you can say that a person needs at least 5,000 to survive. If but the beta the y-intercept, it doesn't have meaning per se in this slope. But now we need to look at the beta coefficient for education. So for every one additional year of education, the salary of the individual will increase by 3,307, right? Here, beta coefficient is negative 8,000. So and the sex here is female. So for female, when the gender of the person is female, the salary will reduce or will go down by $8,950, right? So this is how we interpret it. And then this one negative 5,000, when the person is a minority, their salary will go down by $5,243, right? And then we can create our own equation or prediction model, and we can plug in to predict the salary based on this equation. So this is what you will need to do for the homework. You will need to create your own prediction equation like this, and then show some examples. So R squared, we already talked about it. Adjusted R squared is helpful because in multiple regression, the more you add, the more independent variables you add into the model, the more the R squared will increase. It doesn't decrease, right? So that's why we use the adjusted R squared. So this is the interpretation for this prediction model, right? So we say each year of education increases salary by this, right? By this amount. Experience was excluded because experience was excluded because it was not significant, right? And we will look at it in a little bit right now. And then moving from being male to female reduces the salary by $8,000. Moving from being a majority to a minority reduces salary by 5,000, and so on. So we already talked about this. So now let's have a look and let's build our model that we wanted here, right? So this is the model that we wanted to test. We're going to test it in a little bit. So let's see. So I'm going to go to the Excel sheet. And we'll go to the data set here. And I will go to data, and then data analysis, regression. So again, I already have my input to be the Y. To be the salary. Now for the range, for the input range, do they want me to include education, experience, minority? So from education, experience, female, and minority, right? And then Control Shift, downward arrow to select that, and then everything there. So I need to change in the new sheet. I'm gonna call it education, experience, female underscore minority. All right, so now I have, this is my sheet. I would say, okay, now this is my model. Right, I will highlight the beta coefficient. Right, so the beta coefficient here, I mean the R square is 50%. So in other words, we can say the significant variables in my model explain 50% of salary. So for p-values, you just put numbers here. So they are all significant except for this guy. So the independent variable that is not significant, I'm not going to include it in my in my model. And you see that I didn't include previous experience because it's not significant. So to be significant, my p-value has to be less than 0.05, right? This one is not below 0.05. That means it's not significant, right? So the ones that I need to include in my equation are the ones that are significant and the y-intercept. All right, and also this guy here is very highly significant for the overall model. All right, so now you notice that this is where I got my number from. I got it from here. So I got the numbers from here. And then I got this number from here. And I got this number also from here. But you got the idea now. So we are all set. All right, so that was all that I wanted to show you in terms of how to run your multiple regression. And now you are actually, you know more, you understand more statistics than 99% of the population. So very good. And actually now understanding regression, you will understand the majority of scientific papers in peer-reviewed journals and so on. So that's all I wanted to cover with you today. So all the best to you, and we'll see you soon.